Hello friends, welcome to this channel. In this video I am to explain the important points concerned with the projectile motion. Please listen here. This is the figure we consider to explain the projectile motion. Suppose a particle is projected from A, it travels along D and reaches at B. The time taken to reach from A to B is called time of flight, T. To find an expression for the time of flight, we consider the position velocity relation. S equals ut minus half ut square. Here g is acceleration due to gravity, t is initial velocity, s is the displacement. G is taken as minus because it travels, we consider the movement along the vertical direction. Then the vertical shift, A and B are in the same level, so vertical shift is 0. 0 equals initial vertical velocity u sin theta into t minus half ut square. Then t equals, rearranging, we get t equals 2u sin theta by g. This is the expression for time of flight. For theta is the angle of projection, u initial velocity, g acceleration due to gravity. Now the distance A, B is called horizontal range. It is given by time of flight into horizontal velocity. Time of flight, time taken from A to B into horizontal velocity. Then time of flight, we found that 2u sin theta by g, and vertical horizontal velocity equals u cos theta. This is the horizontal component of the velocity u. So u multiply with u cos theta, we get horizontal range h equals u square sin 2 theta by g, as sin 2 theta equals 2 sin theta into cos theta. Multiply, you get in the numerator 2u sin theta into u cos theta. 2 sin theta, 2 sin theta cos theta equals sin 2 theta, we can substitute here. Then h equals u square sin 2 theta by g. Now we try to bring a relation to time taken to reach maximum height, which is CD in the figure. Maximum height reached is the CD in the figure. Let T1 be the time taken to reach at D. The projectile is projected from A and reaches at D. So time taken to travel from A to D is given taken as T1. Then at vertical velocity is 0 here. At this point the vertical velocity, final vertical velocity equals 0, beyond which the projectile don't go up. So v equals u minus g t1. Vertical velocity v equals 0 here. Then u sin theta is the vertical initial velocity minus g t1. So t1 equals u sin theta by g, which is the half of the time of flight t. T1 t by 2. So t1 equals t by 2, half of the time of flight. Then maximum height reached can be found by average vertical velocity into t1. Average vertical velocity means initial vertical velocity plus final vertical velocity by 2. Average initial vertical velocity u sin theta plus final vertical velocity 0 all divided by 2 into t1. T1 equals u sin theta by g. Then you get u square sin square theta by 2g. This is the maximum height reached. This relation we can also found by considering the velocity position relation. At d, v square equals u square minus 2gs. Here s equals cd, maximum height reached. So At D, vertical velocity 0. So u sin theta whole square minus 2gs. So SC equals u square sin square theta by 2g, which is the maximum height result. Maximum height result can be found in two ways. One is this, first is this, second is this. That's all about projectile motion. Thank you very much.